Hi, we are Karina Barth and Marcos Sterzi, and we are presenting the paper Implementation of Production System Design in House Building Projects, a Lean Journey in Chile. The other authors are Carlos Formoso, Juan Ignacio Alliende, Daniela Bertín, and Jorge del Rio. There were 3 agents involved in this work. The first one is Empresa Socobesa, the largest real estate group in Chile, where the projects were held. The company is promoting a major lean transformation process. The second agent is Alliende Consulting, a consultancy company from Brazil responsible for the lean implementation program. The third agent is Noriuris, a research center in the Federal University from south of Brazil, co-responsible for the lean implementation program. We have performed a literature review on production system design. And concerning the construction industry, the PSD translates the production strategy into a set of decisions. These decisions establishes a structure to manage different activities and also creates conditions for control and improvement. The PSD consists of developing operation and process design in alignment with product design, the structure of supply chains, the allocation of resources, and design for assembly efforts. The PSD also involves a set of interconnected decisions, and the PSD can potentialize the benefits of the last planner system, allowing the early identification of a larger range of problems. This paper reports the experience of a construction company that has implemented production system design and the last planner system over 3 years. This work is part of an ongoing lean implementation program. The contributions of the paper are the definition of the scope and the potential benefits of the production system design, and the proposition of a set of practices that can be used along the production system design stages, with emphasis on location-based planning and control. So, the implementation was divided into 3 main phases. In phase 1, for assessing the existing situation, an evaluation protocol was applied in 2 projects, and we also took other sources of evidence. We find out that the company did not have a systematic and explicit PSD. Also, we identified a lack of understanding of lean concepts and a large amount of work in progress. Phase 2 was characterized by the development and testing of PSD and last planner system. During this phase, a lean training program was carried out. Also in phase 2, an evaluation of benefits was performed. As results, a lean supporting group was established, a decision category was included to emphasize layout and logistics, and some control tools were standardized. During phase 3, the LPS and PSD model were implemented in 5 new projects. After the implementation, the results were evaluated and the model refined. A lean workshop was organized to discuss and disseminate the benefits of implementing PSD.
The PSD company's model has 8 category decisions. The first 3 categories are related to the base unit, or repetitive batch. The other ones are related to the project as a whole. The PSD starts with the capture of stakeholders' requirements and definition of construction sequence. The second step is to define resources and production capacity. In these 2 steps, BIM can help gather information and to communicate clearly the construction sequence. The third decision category refers to the definition of workflows. It may be necessary to make a trade-off analysis between product flow and workflow. The definition of workflows may require a review in the previous steps. Categories 4, 5, and 6 present a higher interaction. It begins with the definition of the execution strategy. Here the goal is to divide the project into small work areas, establishing a location-based system, and to define the execution path for base unit processes and critical processes not included in the base unit. The decision category 5 provides a deeper analysis of layout and logistics. More than defining construction facilities, it's important to analyze and simulate where and how the flows will take place. In the 6th category, the first version of line of balance will be developed. During this step, it's important to balance the cycle time of the processes based on takt time. It's also important to set buffers to decouple processes with high level of uncertainty and variability, as shown in the example. There are some critical processes that may limit the system capacity. Those processes need a close look in order to anticipate problems and reduce uncertainty. Here we have an example of a workstation map for concrete structure that shows in a transparent way the result of the design for a critical process. The last step is to perform a review of the previous categories. Based on the decisions taken in the design of critical processes, some changes may be necessary.
At the end of Phase 3, 6 main benefits were identified throughout a lean workshop. The first 2 benefits are a consequence of the early involvement of stakeholders in pre-construction phases. The use of data and the experience of different stakeholders helped to explicit decisions and reduce uncertainty during the construction phase. Still, PSD helped improving planning accuracy by exploring multiple alternatives of construction systems and subsystems. Planning accuracy was monitored during the construction stage by batch adherence control. PSD also facilitated the adoption of cycle time and takt time control. In addition, stakeholders that participated in the PSD decisions become more engaged with the less planner system, and the projects improved production stability. Less planner metrics and the sequence of work in progress control were used to monitor these benefits. So, for conclusions, we have compared the proposed PSD model with previous studies. Differently from other studies, the proposed PSD model was tested and implemented on several residential projects in a systematic way. It also provides more emphasis on location-based planning and control, layout and logistics studies during pre-construction stages. The PSD proposed advances in terms of cycle time, takt time, work in progress, and synchronization analysis before construction. It generates information concerning the production system as a whole. It also produces a set of standardized tools to be used to monitor the implementation of PSD. Also, data have been collected by the research team, and in the near future, the main results achieved will be systematically reported. It is important to highlight that although PSD requires a collaborative effort in the pre-construction stages, the proposed model do not seek to increase the level of detail of decisions in those stages. In other words, it does not conflict with the adoption of different hierarchical planning levels proposed by LPS. We would like to thank the Socobesa Group project teams for their commitment in the implementation process, and in special to engineer Javier Sanchez for his support and contribution to the Lean implementation program.
So feel free to contact us for further information. Thank you.
Thank you.